Excellent. Thank you very much. And good morning and good afternoon to everyone. Thank you for joining. Really excited to have the opportunity to share with you some information about our new vSphere 6 launch that just occurred about a month or so ago. Before we jump right into some of the new features and what's new from a tech specs perspective, just wanted to give you a quick overview of our software-defined data center strategy. This is something that you may have heard of, hopefully you've heard of, because we've been messaging this for about a year and a half. Really, the idea around the software-defined data center is that this is the ideal architecture for cloud computing environments, both on-premises and then off-prem, particularly in our own hosted cloud, vCloud Air. And so that's what we mean by hybrid cloud, is the scenario where some of your VMs are running on-prem on top of vSphere or maybe another hypervisor, and then some of your workloads, your VMs are running in the cloud. And so only VMware and only our software-defined data center strategy has the products that allows you to manage all of those workloads, whether they're on-prem or in the cloud, from a single pane of glass. It's a single management interface for operations management for those different VMs that are both in-house and in a cloud provider, as well as automation tools and so on and so forth. And then at the bottom there you see compute, networking, and storage. So that's what our platform extends over to pool and abstract resources. vSphere, of course, is our compute virtualization flagship product, but we've gotten into the networking and storage spaces as well over the past year and a half. So in the networking side, our network virtualization platform is called NSX. That's a technology that came to VMware about 2 years ago through the acquisition of a company called Nicira. And today we're seeing a lot of uptake of NSX inside of our customer base. And then on the storage side, about a year ago we launched a product called VirtualSAN. And so as of this vSphere 6 launch, we actually revved VirtualSAN to VirtualSAN 6 as well. So there's some new capabilities inside of VirtualSAN, which allows you to pool local storage in your ESXI hosts and then use SSD drives in each host to do read caching and write buffering, and basically take all of that raw local storage and pool it into one big storage array available for the hosts in that vSAN cluster. So it's an exciting technology. We won't talk too much about that in today's presentation, but just wanted to make you aware of where we're at and how this software-defined data center vision is shaping our product strategy. So that said, we'll just jump right into it. With vSphere 6, with this launch, we've raised the ceiling on a number of kind of maximums. So now with vSphere 6, our clusters can support 64 hosts per cluster, excuse me, and 8,000 VMs per cluster. And we can also support 480 physical CPUs and 12 terabytes of RAM per host, as well as up to 1,000 virtual machines per host. So those are some extreme kind of maximums. I don't know how realistic those limits are for the environments that you're working in, but just know that as with almost every single release of ESXI, we're raising the ceiling on what the technology can support. And then also at the virtual machine hardware level, with vSphere 6, it's virtual hardware version 11, we can support 128 virtual CPUs assigned to a single VM, as well as 4 terabytes of RAM assigned to a single VM. So a couple of other minor things that we're making available in Virtual Hardware 11. XHCI support 1.0 allows for USB 3.0 devices to run at full speed within the VM. And then we've also made some enhancements along the lines of serial and parallel ports, where a VM can now have a maximum of 32 serial ports, and we can also detach or remove serial and parallel ports from the virtual machine's hardware configuration. So that's relevant for customers that like to strip out all of the totally non-essential hardware inputs and interfaces that the VM has in its configuration. So just know that that's available there. And then we've made a number of advancements with respect to vCenter Server. So probably most notably is that the Linux version of vCenter Server that's available as a virtual appliance that you can download and deploy now is on par from a scale perspective with how many hosts it can support, how many powered on VMs, how many hosts per cluster and VMs per cluster, and so on and so forth. So in the past, the vSphere Server virtual appliance was was something that we would recommend maybe for branch office deployments or small office deployments of vSphere. But today now you can see that this is really something that you can consider to use instead of a Windows instance of vCenter Server. It's easier to support and maintain from the perspective of you don't have a Windows operating system who you have to patch and maintain the life cycle of and so on. And it has a very small attack surface, if you will. So it's a virtual appliance that's been hardened and locked down. So this is something that you can consider deploying in your environment. And then most notably, I think, if you notice the bottom there, linked mode is supported with the virtual appliance. So this is something that was always a showstopper with the virtual appliance in the past, is that it did not support linked mode since that was kind of a Windows-centric service that ran, so it required the Windows vCenter Server instance. But today the virtual appliance supports linked mode. And it also supports linked mode between Windows instances. So you can mix and match Windows and Linux vCenter Server instances in your environment and have them all participate in linked mode. And I'll talk about that more in just a second. But from a database perspective, the Windows install of vCenter Server supports Postgres and SQL and Oracle, and then the Linux appliance supports embedded Postgres and external Oracle. So just one consideration there is that the Linux appliance doesn't support Microsoft SQL. So something else that I just wanted to make you aware of with respect to the vCenter Server appliance is that it is possible to migrate your Windows vCenter Server directly over to the Linux appliance. So the tool that we have available for that is the VCS to VCVA converter. But what this is a fling. So I just want to give you a quick disclaimer about flings. If you go to vmware.com/flings, that'll bring up kind of a repository of these different kind of projects or initiatives that our engineers take on in their free time, just to kind of take an idea, flesh it out into a product or utility or tool that's available for free for use. So there's disclaimers around support and things like that. It's one of those things that use these. If they're useful to you, that's great. Please provide feedback and so on and so forth. So this is not kind of a production supported utility, but instead something for you to just take a look at and see if it's useful in your environment. So it's a non-destructive migration, so if the migration doesn't work, it does not destroy your old vCenter server or anything like that. So just wanted to make you aware of the VMware flings in general, and then this fling around migrating from a Windows vCenter server to the Linux appliance. So one of the new components under the hood inside of vCenter Server is what we're calling the Platform Services Controller. And so what this is a name for this set of capabilities that exists under the hood in vCenter Server that can also be deployed on a standalone server, so as you scale out. And it's really starting with a single sign-on server, but also bringing in the licensing as well as the certificate authority capability. So that as you scale out across your environment, every vCenter server that you upgrade to version 6 will essentially have the Platform Services Controller in place. And then for scale reasons or design considerations, it's possible to have the Platform Services Controller exist on a separate server apart from vCenter Server. So just know that that's there. But really what this Platform Services Controller brings to the table is new replication technologies, and so this is what allows us to have linked mode exist between Linux appliances as well as Linux to Windows instances of vCenter Server. So it has a native replication technology that we're using to replicate roles and permissions, your VMware product licenses, policies inside of your vCenter Server environment, as well as the inventory tags. So all of that can be replicated now using the Platform Services Controller, which is put in place automatically as soon as you install or upgrade to version 6 of vCenter Server. And so that's closing this huge gap that we've had in the past. So you can see that the linked mode that we had in the past could not replicate policies and tags, and it was based on Microsoft's Active Directory application mode, essentially just kind of a canned instance of AD that was used for applications. And now today we have much more capability. So some very big advancements there, and now linked mode will work across, again, Windows and Linux instances of vCenter Server in your environment once you upgrade them to 6. So another big advancement with vCenter Server 6.0 is cross vCenter vMotion. So what we're doing here is supporting simultaneous changes to a VM's compute environment and storage and network and vCenter. So we're doing a regular vMotion, which is changing the compute resource that VM is running on. We're doing a storage vMotion, which is migrating that VM's VMDK files from one data store to another. We're doing a network vMotion, which is migrating the actual network infrastructure, the virtual switches that VM is communicating over, and we're also migrating it from one vCenter inventory to another. All of this simultaneously without shared storage in place necessarily, or without a requirement for shared storage. So this is a significant advancement. On the network side, we can migrate across distributed switches, or between standard switches, or from standard switches to distributed switches, and so on. And the target topology here is local or metro or cross-continental configurations of vCenter server environments. Which kind of leads us to the next one here. Long-distance vMotion is something that's supported now. And so this is the same type of vMotion that I just mentioned on the previous slide, but with some more details around performing this specific type of vMotion. So in this case, what we're supporting is a vMotion where the round trip time, the latency is 100 milliseconds or less. And so that's really kind of the main requirement. And then another requirement that we have really around so that there's no disruption to the VM is that layer 2 is consistent across both the source and destination sites. Because with a vMotion operation, we're migrating a running VM and changing that compute resource as well as the inventory that it's in for vCenter and the underlying storage and so on. When that VM arrives in your destination location and it's running, if layer 2 networking is not consistent, then its network configuration is not going to allow it to talk on the network there. So the VM will continue running, but it won't be accessible. So unless somebody manually changes it. So, for a vMotion, we talk about a zero downtime or zero disruption migration. So that's why layer 2 really needs to be configured properly between the two locations so that the VM's IP configuration, when it arrives at its destination, allows it to just talk seamlessly on the network there with all the other resources. So there's some different use cases for this type of vMotion. Disaster avoidance is a great one, as well as permanent migrations. So if you're going to be closing down a data center and you're moving to another location, you no longer necessarily need to power down those VMs and do a cold migration or replicate them over to the new location or transfer them to disk and ship them. Right now, depending on what the latency is like between your locations, it's possible potentially to just migrate that running VM from one site to another as a part of it, just kind of like a permanent relocation of that VM. And then also disaster avoidance. We talk about DR with some of our DR and business continuity products, like Site Recovery Manager and vCloud Air Disaster Recovery. But in this case, with vSphere 6, I can potentially just see that, hey, maybe a hurricane is descending upon, the New York, New Jersey area as it was 2 years ago, and it's all the media is talking about for 2 or 3 days leading up to the event. That could be my window of time to just proactively migrate my running VMs to other offices, other locations where, they're not prone to that risk of that disaster. So, and then also follow the sun scenarios, which I don't really see as often with the customers that I talk to. But if you need to have VMs in a current time zone relative to where the users are accessing them, then you could have VMs just kind of programmatically vMotion around your environment, and then also multi-site load balancing. So this is definitely one of the most talked about new capabilities of vSphere 6 is the ability to vMotion, again, beyond the confines of a cluster of your vCenter environment across different networks as well as across large geographic spans of space. So another feature that's inside of vCenter Server 6 is the content library. And so what this is a feature that I really like. It's a basic way to manage a lot of the stuff that an admin has to maintain inside of a vSphere environment. Stuff like ISO files, templates, OVFs, and so on and so forth. And so the content library is basically a replication service that replicates content across hosts, and it's like a publish and subscribe type model where you decide which hosts will pull what content, and that content is replicated down to those hosts and so on. So it gives you an interface through the vSphere web client, where you can put in some metadata around, this content, who created it, what is this ISO, why is it here, what is the date that it was introduced, and so on. And you can put, this is the Windows Server 2012, R2X, this version of that, and so on, and it's here for these workloads, and so on and so forth. So in the past, virtualization admins oftentimes just had, it's basically a junk drawer of stuff, some data store where they just kind of put all of their random, OVFs and templates and ISOs and so on and so forth. And now this is a more proper kind of content management solution on how you can store that centrally for your VMware environment and kind of replicate that content around. So, and then the other thing to know about this is that this capability, its roots are actually in one of our legacy products, vCloud Director, which you might be aware of. So vCloud Director was a product that we had in the past for infrastructure as a service that's since been replaced by vRealize Automation. It used to be known as vCloud Automation Center. So when vCloud Director was announced that it would be sunsetted, we said that some of the features that are unique to it will be put into vRealize Automation, its successor, but we also said some of those features will also make their way into vCenter Server. And so this is an example of a vCloud Director feature that's now just been made a part of the core vCenter Server product. So shifting gears and talking about clients a little bit, as you probably know, we have two different clients that you can use to access your vSphere environment and manage it. And so there's the web client as well as the traditional Windows-based client, or as some people call it, the C# client. And so so this is just a quick chart that will show you the differences. Today, the web client really should be used for most of your administrative activities. The only thing that really is a gap still is with Update Manager. So if you're using Update Manager to do some patching of your environment, some of those features are available in the web client, but some are not. In fact, if you're studying for the VCP 5.5 exam or updating your 5.0 VCP to 5.5 before you go to 6, there's actual questions on what's in the web client versus the vSphere client when it comes to Update Manager. So I'll just give you that little tip. But anyways, the rule of thumb is for the web client, that's where new features that get rolled into vSphere, kind of like the shared nothing vMotions and the cross vCenter vMotions and so on that I was talking about earlier, those are only really invocable or kind of manageable through the web client. So the vSphere, the traditional Windows client might be your go-to because that's the old friend, that's what's familiar and so on. But definitely start looking at the web client more. In fact, here's a couple of reasons why you maybe want to revisit the web client once you upgrade to 6. So they really invested a lot in the performance of the web client, making it more snappy, responsive, and so on. They also increased the usability of it. So from a performance standpoint, login to the web client is now on average 13 times faster, which is just obviously a tremendous improvement. So the web client isn't going to sit there with the loading VMware logo for 10, 15, 20, 30 seconds potentially. Now it's much more snappy. And then if you take a look at just this bar graph here, you can see that for all these different inventory items that you might view, the response time for the client to access that information from vCenter Server through the web client is significantly faster. So the green bars are obviously, the way it stands now with version 6. So the response time is much, much lower than it was in previous versions of the web client. And so we also have a number of usability improvements. So now you can right-click and get anywhere, really, in the inventory in a single click. Right-click has been significantly flattened, so it's not as nested as it used to be. And then recent tasks have been put back at the bottom of the screen by popular demand, similar to how you would see it in the vSphere Windows-based client or C# client. And then the UI is actually dockable, so you can kind of rearrange some of the elements inside of the web client to your preference. So some customization capability that you have in the web client. So like I mentioned, once you get to 6, definitely try and start using the web client again, and I think you'll be pleasantly surprised with the performance improvements. So another huge area of improvement in vSphere 6 is around fault tolerance. And so just as a reminder or a refresher, fault tolerance is the ability to have a single VM protected in the case of a host failure. So if there's any type of failure to that host, that VM that's been made fault tolerant has a second instance of it running kind of as a shadow or ghost VM on another host. And as soon as that heartbeat between the two is broken and that host is not accessible or that primary VM is not available, the secondary VM becomes the primary. So essentially the memory is all being synchronized and so on. And in previous versions of fault tolerance, both VMs use the same VMDK files. So one of the limitations that we had in the past prior to this release is that we didn't support multi-CPU VMs for fault tolerance, which is oftentimes a showstopper for customers because their most critical workloads are the ones that they want to make fault tolerant, and oftentimes those VMs have multiple CPUs because what they're doing is significant and they need significant compute resources. So in the past, that was just a showstopper for fault tolerance. Couldn't turn it on for that VM if it had more than one virtual CPU allocated. So today we'll support up to 4 virtual CPUs and 64 gigs of memory on the VM. And so at the host level, we'll support up to 8 vCPUs total across VMs for fault tolerance, or a maximum of 4 fault-tolerant protected VMs per host. So there's a significant overhead of traffic for fault tolerance that's generated because of this. And so that's kind of why these scale maximums are set where they are. Although in tech previews, I personally have seen up to 16 vCPUs set up in fault tolerance. So I wouldn't be surprised if they increase these maximums as future releases of vSphere come out. So that's what is new with fault tolerance. We also support backing up fault-tolerant VMs using products that support vStorage APIs for data protection. So these products are snapshot-based backups, including our own vSphere data protection. In the past, you could back up a fault-tolerant VM, but it had to be agent-based. You had to put a backup agent from a backup vendor into the VM and back it up that way. So not getting any of the benefits of vStorage APIs for data protection. Now this is fully supported with fault tolerance in version 6. And then there's also been a change under the hood. So I mentioned in the past, your fault-tolerant VM, the primary and the secondary used the same VMDKs, and one just had kind of read access to them until it was flipped over and made the primary. Today now, in version 6, fault-tolerant storage has changed, and the VMDK files for the secondary VM are separate from the primary. And so this allows you to actually put those VMs on separate data stores if you wish. So you have some flexibility there and so on. Okay, and then also included with vSphere 6 is vSphere Replication. So this is just a replication technology that used to be available for use with Site Recovery Manager, but now it's just generally included for free with vSphere. We made some enhancements on the vSphere replication side. Probably most significantly when it comes to end-to-end traffic, there's now compression that's in place, and I've seen the compression ratio as being advertised as between 1.7 to 1 all the way up to 2 to 1. So some significant bandwidth savings there with respect to replication traffic and the compression that we can do before we send it across the wire. And then we can also now separate the network traffic for vSphere replication separately, so that just as how you would separate off fault tolerance traffic and vMotion traffic and management traffic on your virtual switches, we can now separate out replication traffic as well. And then we also support quiescing of Linux file systems inside of Linux guests for replication operations. So another big announcement that we have, and this is the final one, is around vSphere data protection. So hopefully you're familiar with data protection because it was the successor to our old backup and recovery utility that we used to bundle with vSphere, which was called VMware Data Recovery. About 2 to 3 years ago, we announced vSphere Data Protection, which is kind of an entirely new product that was developed in conjunction with our EMC counterparts. And so a lot of the technology under the hood in data protection is based on Avamar. So definitely a huge benefit to the relationship that VMware has with EMC. Avamar is an elite enterprise backup and recovery solution, and so we're taking advantage of lots of the secret sauce in Avamar inside of vSphere data protection around change block tracking and deduplication ratios and things like that. So all of data protection is managed through the vSphere web client. So there's another example of why you should be shifting gears and moving over to the web client as your daily driver. And so previously we had two versions of data protection. We had an advanced edition, which you would pay for, and we had a free version. But today, with vSphere 6.0, we've collapsed those two, and so the advanced edition has become the free version. And we don't have a kind of a premium version anymore. So there's just vSphere data protection in 6.0, and this has all the features that previously you would have to pay for. Now they've all been waterfalled down into the free version that just requires that you have vSphere under maintenance. So up to 8 terabytes of deduplicated backup capacity per appliance, and you can deploy 10 of these appliances inside of your environment, so 10 per vCenter. It's agentless backup and recovery, but we also do have backup agents for your VM guests that are running SQL Server, SharePoint, and Exchange. So now you can actually do application level backup and recovery, so you're not kind of restoring an entire SQL server just to get back to a certain point in time with a certain database on that server, right? So we're leveraging the APIs from Microsoft for backing up SQL, Exchange, and SharePoint, and so we have a specific backup agent that you can deploy just to those guests to do kind of beyond the VM level backup with the application level backup. So in addition to what I mentioned previously with vSphere replication, oftentimes as a point of confusion, we actually have a replication capability built into vSphere data protection. So this is separate. This is, again, kind of built on the EMC technology. What it allows you to do is replicate completed backup jobs, backup data, from one vSphere data protection instance to another. So we have that 8 terabyte capacity max, for the virtual appliance for vSphere data protection, but you can free up some of that space just by replicating completed backup data off of that and onto other instances. So oftentimes customers will put vSphere data protection virtual appliance in a remote office. It'll do backups there, and then it'll replicate those completed backups back to their main location, and then their main location will have a VDP appliance. It'll do its backups and then replicate the completed backup jobs off-site. Right, so it's a very simple way. You just configure replication between the two appliances. That's all done within the web client under the vSphere data protection area. So this is its own native replication that's different from vSphere replication. So if you are an EMC customer and you use Data Domain, then you can actually use Data Domain as the backup repository. So instead of the 8 terabyte limit with the virtual appliance, you can just point it straight at a Data Domain instance, and then it will simply make that the destination for all the backup data. And that's very simple to put in place. So we're going to shift gears now, and I'll turn it over to my colleague Andre to talk about securing your vSphere environment. But I just wanted to give you a quick heads up that if you don't know about it already, we have a hands-on lab catalog online that's free for everyone to use as much as they want. It's at labs.hol.vmware.com, and that's where you can go and kick the tires in a live environment. Labs are all provisioned on demand just for you, and you can take them as many times as you want, and they have lab manuals. They walk you through different scenarios for different products and that sort of thing. So if there's anything in here that piqued your interest, or you have questions about other VMware products, you can actually play with them yourself and have the guidance of a lab manual to assist you if you just check out our hands-on labs. So thank you very much for your time, and I'll pass it over to Andre.
Thanks, Sam. My name is Andre Pazhogin. I'm Senior Product Marketing Manager with Kaspersky Lab. I'll be talking about security for virtualization. I hope you can hear me all right. In case you cannot hear me, please use feedback button to try to flag for me. It'll take you about 5 minutes to get used to my thick Russian accent, so bear with me. I've got a few introductory slides. Normally, I do overview a threat landscape, but it's 2015, and I hope you read news. You see a lot of headlines that are generated by cyber events. And whenever you do a virtualization project, you probably have got a lot of pressure, and a lot of things tend to be intentionally or unintentionally forgotten in the course of the project. Unfortunately, security tends to be one of the things that is not taken into considerations immediately. And this is just not a good way to go, because the number of threats has been growing exponentially in the last several years. They not even double, they multiply significantly. Old ways of protecting your environments just does not work now. For example, signature-based detection that is able to pre-clean traffic, probably take out 80% of the threats from the traffic. This type of protection only works with the known threat. But the remaining 20% is a mutating type of threat that nobody has signatures for. It's super easy to create a new variation of a threat and just send it somebody's way. So I don't think anyone wants to be left face-to-face to those remaining 20% of the threat. And even if you've got the signatures for every single threat nowadays, you still have to maintain a database of those signatures. So the databases grow bigger and bigger, and it's kind of important in virtualized environments. We'll see why later. So you should not be even considering an option of postponing the protection of virtual environments. There is a myth that a virtual environment is more secure by the nature of it. Some people think that if they got infected, they would just kill a virtual machine and recreate a new one from a template. Well, nowadays we see even threats that are specifically designed to work with virtualization. For example, to find virtual machine files and modify them in a way that the next time you boot a virtual machine, the malware will reside already in the operating system of the virtual machine. So having no protection for virtual environment is not an option. And we've been asking people at local VMARKs if they have protection, and if they do, what kind of protection they use in virtualized environments. Several years ago, quite a few hands would fly up when I would ask who does not have protection in virtual environments. Fortunately, we saw it changing. I barely see a single person these days who would say he goes without protection. So it's good. Option number 2 is agent-based. Everyone got used to this. Normally would just take the conventional security, deploy it into virtual environments. Good news is that security-wise, it's nearly perfect. There are some threat vectors that would be exploited by bad guys, but I would say that the chance of exploiting that, one of them is being instant on gap, and I'll talk to it a little bit more later, is very slim. So agent-based is a good solution. However, it's not the only one, and it's not the best one in virtual environments. Option 3 is agentless protection, and option 4 is light agent protection. So now let's have a look at all of them and compare them. First, agent-based security. This is the I would say most comfortable option for many, because they've got people trained with the conventional antivirus. It's kind of easy to manage. It's easy to deploy. Nothing new here. The thing is that the replicating the security solution across all the virtual machine is basically redundant. You have to store a database of definitions of malware files across all the virtual machines. And with the database growing bigger and bigger these days because of the growing number of threats, that takes a lot of storage. That also generates a lot of requests to storage system. It generates a lot of load on CPU and RAM of virtual machines. And there are scenarios when this basically takes a huge hit on performance. Just being several of them, for example, update storms. Imagine all the employees come to the office at 9 o'clock, switch on their desktops, and those desktops will be virtualized. So the agent on every single virtual machine would reach out to the update server of security company and try to download the updates. This basically clogs all the virtual network and draws the virtual machines responsible for quite a lot of time. Another thing is temporary security solutions are trained to be flexible and to react to a security instance. So, for example, if a security solution thinks that there is a virus outbreak, they would change the policies and apply the paranoid policies. So things like heuristic, for example, will be tuned up, and it will start unpacking all the files, huge archives, huge disk images will need to be unpacked and analyzed thoroughly within the virtual RAM. This again creates a huge impact on the performance of the whole system. But again, let me just repeat myself. Security-wise, this is a good solution. What we are talking here is efficiency and consolidation ratios. We estimate that using a conventional security solution makes you use about 1.3, 1.5 times more hardware to work with the same performance level as you would do with the security solution specifically designed for virtual environments. So yes, there are better ways to protect virtualized environments from malware. Number one of them is Agentless Security. It uses vShield API from VMware. Basically, it takes a virtual security appliance. It's a pre-configured virtual machine that you can download from our servers. It takes very little configuration, basically putting in credentials and just hooking it up with Security Center by Kaspersky and vCenter. I myself saw a system engineer setting this up in under 40 minutes. So it stores a single database of the definitions, and I don't believe I mentioned that, but the footprint of an agent-based solution is anywhere between 1 gigabyte and 3 gigabytes. So imagine this replicated across, 100, 150 virtual machines on a single host. How much storage does it take? So with the virtual security appliance and agentless security, just one database in on the virtual security appliance. So how does it work? A virtual machine, whenever it needs to check a file, it generates requests to virtual security appliance. Right. Basically, it asks the virtual security appliance to give the verdict, and we can do amazing things now with that. So virtual machines would have most of the files on them be Windows files, so they are also redundant. And whenever we see a file that we've already checked, we can store a local cached verdict for that file. And whenever we see another request for checking that file, we would give the verdict out immediately without spending any cycles on doing the work again with the file. It takes out the resource consumption. It eliminates update storms because now the virtual security appliance is always on. The copy of the anti-malware definitions are always current, and it allows higher virtual machine densities because there's just one copy of the database. And whenever a new virtual machine is deployed or just switched on after a long shutdown, it will be immediately protected with the newest definitions because the virtual security appliance is always updated. So it's a great solution, always on. It significantly reduces boot latency and increases consolidation ratios and operational efficiency. So shared cache I told you about, and so what it does basically, there is a report from Tolerant Group released in 2013, August 2013, that measures that kind of operation with shared cache and without shared cache. And you would see that the first check, on-demand check on the virtual machine would take quite a long time, but every following check would take probably 7 times less of the time because we store the verdict for all the files we've already seen. Let's have a look at the architecture of how it works. Here you can see the unprotected VMware ESXI host. Every single virtual machine has VM tools deployed, and as a part of VM tools, you would have a vShield API. It's controlled through vShield Manager and vCenter server. All you need to do is to download the pre-configured virtual machine, virtual security appliance, and have a Kaspersky Security Center set up in your infrastructure. And that virtual security appliance will talk to vShield basically, use it as a pipe, and whatever it gets from that pipe, it will check and send the verdict back to that pipe. So we don't need to do any deployment on the virtual machine. That's why the procurement is super easy. You just need to basically start the virtual security appliance. It will do the protection for files. If you need the protection for network, we can do things like IPS, IDS, and we can scan traffic. For this, we are using a similar pre-configured appliance called Network Security Appliance, and it works through VMware distributed switches. We need just one per vCenter, unlike for file security, where you need one per ESXI host. So again, you just download it, you deploy it in a matter of minutes, and it works with the same instance of Kaspersky Security Center for management, and no deployment is required for the virtual machines. All the traffic is rerouted through the virtual appliance, so it analyzes packets and analyzes the headers of the packets, and is able to clean a lot of malware from the traffic even before it hits the virtual machine. Thus, again, lowering the security overhead for the whole infrastructure. This is the graph I wanted to show you from the Tolerant report I already mentioned. It basically compares 3 solutions designed specifically for virtual environments, and one solution designed for its conventional agent-based solution in yellow, and you can see how badly the agent-based solution scales in virtual environments. And make no mistake, in this case, the graphs are yellow, so you can kind of guess the vendor, but you could actually paint it any color, If it would be Kaspersky agent-based solutions, will show the similar results. My point is basically by going the conventional way, which is probably more comfortable for you, you are paying a huge security tax on in the virtual environments. This is not a good way to go. You should choose one of the two options for virtual environments. If you don't care about consolidation ratios at all, for example, you've got one server sitting on a beefy virtualization host, you can go with the agent. But if you try to maximize the use of virtualized resources, you need to be looking away from the agent-based security and use either agentless or light agent solution. I wanted to mention, since the first part of the webinar was on vSphere 6.0 support, we are right now in process of certification with VMware, and we will be releasing the service pack to our agentless application later, probably by the end of the summer. Next option I wanted to talk to you about is Virtualization Light Agent. It's a patented technology. Kaspersky has just got a patent for that. It operates somewhat similar to the agentless option in a way that we also have a virtual security appliance here that has a single anti-malware definition database sitting on it. But now we have software deployed to every virtual machine. This can be done using software deployment tools from either Kaspersky or virtualization platform vendor or any configuration management software. It's super easy. It's not as easy as Agentless, definitely, but it wouldn't take a lot of time to deploy that piece of software. But now we have access to the internals of every single virtual machine through that light agent. Again, this does not have the drawbacks of the agent-based approach. Here's how it works. You have a virtual appliance. It's a similar appliance to the agentless solution, which works with every virtual machine. But in this case, it does not use vShield. It uses Kaspersky Light Agent and TCP/IP as a protocol to talk to virtual machines, and it brings in that functionality, which is an extra that is able to cover that 20% of malware that cannot be caught through signature-based or heuristic detection. And additional security tools such as web control, device control, application startup control and privilege control, firewall and network attack blocker. We can do it now within the virtual machine. And we can do the vulnerability monitoring, and even with the additional tools, we can do patch management in several cases where in case the virtual machines are persistent. It's also more robust solution than agentless in a way that in case with agentless, if for some reason the virtual appliance becomes unresponsive, the guest virtual machines become unprotected, and there is no fallback solution for this case. In case of light agent, the guest virtual machine, if it doesn't see the virtual appliance, it would ask the Kaspersky Security Center what it shall do, and all requests for anti-malware will be rerouted to the virtual security appliance on the other hosts. It will generate some more load for the virtual security appliances on other hosts, but at least the guest virtual machines will remain protected for the time of recovery. Here's again a feature set of Light Agent solution, file and network protection locally within the virtual machine, host intrusion prevention system. We can do anti-banner, anti-phishing, anti-malware, and anti-rootkit scans. We can do application, web, and device control. We can now not only look at the files, but we can look at what they do and how they do it. We are able to see the behavioral patterns, and that allows us to do amazing things with automatic exploit prevention system, where we can block malware like, for example, cryptolockers. But then, even if we miss that, and if we allow to execute that type of malware, we'll still be looking at the system, we'll still be logging the changes made, and during the execution, if the pattern rises a red flag, we are able to roll back changes made to the system, and we are able to roll back the encryption of the files, which is made through local protected backup of user files. Now, because we don't use vShield, if you have a heterogeneous network, if you have, for example, VMware for VDI and Citrix for servers, so vice versa, you can use Light Agent across platforms from VMware, Microsoft, and Citrix. So let's have a difference of approaches to the security. Agent-based, again, as I showed you on the graphs, is not scalable at all. However, if you have a lot of resources, you can use agent-based protection. Security-wise, it's next to ideal solution. There is one issue with instant on gap, which potentially can be exploited but I estimate the chance of that being very, very low. If you are counting resources, if you are trying to rise the consolidation ratio, Agentless is probably the best solution for the highest consolidation ratio possible. However, security-wise, it may have some drawbacks, just because not all the technologies can work with vShield, and we cannot see the internals of the virtual machines. We can only work with the files there. So it's an ideal solution for data centers and for server environments. It takes no deployment, well, almost no deployment. It's super fast. It provides highest consolidation ratio possible. And you don't have users browsing internet in the data center, so it limits the exposure area to threats, so it's good. If you keep loading the virtual machines in agentless scenario on the host, it will eventually hit threshold on storage IOPS, just because the database still needs to be checked for every single file request. And eventually, if storage IOPS is not an issue, then VRAM will be limiting factor. Light Agent is optimal balance between security and efficiency. It provides somewhat smaller. It allows somewhat smaller consolidation ratios than Agentless, but not significantly. And it provides the best security. It brings the feature stack of agent-based within the virtualized environments with almost no security tags. We now have confirmation for that. In 2014, AV-Tests released their report where they compared the Light Agent solutions, and Light Agent indeed provides the best protection at the smallest expense. Here are a few graphs from that report from AV Test. On the left one, it's average disk queue length. Gray line is unprotected machine used as baseline. Green line is the performance by Kaspersky, and yellow and red is our performances by Kaspersky competitors. So you can see there is a little security text, but not as big as agent-based solution in the yellow case and agentless solution in the red case. And on the right, there is a boot time per virtual machine. So it slows down a virtual machine, and it's, by the way, VDI environment, so it does slow down a little bit VDI, but it provides the best performance across the solutions in the industry. Just to recap, here we have 4 options. No AV is not an option. However, it's definitely the fastest and the most efficient speed-wise solution. Agentless is the optimal performance and optimal security. Agentless is the best speed but good security. Light agent is optimized, and agent-based is the best security possible, but it is not efficient at all in virtual environments. So we would not, in most cases, we would not recommend to go with the agent-based approach. A few words about Kaspersky. We are a private company. We were started by Eugene Kaspersky, our founder and CEO. He used to work himself as an anti-malware analyst. His last shift, I believe, was in 2006. So he's very obsessed with the anti-malware performance we show in the independent test. So he basically pays us on our results in the independent test. That's why we test more than anyone in the industry. So here we put all the independent tests made during past several years. We test the most in the industry, and we win the most first places, and we more often end up being on the first, second, or third place. We are very proud of it, and all of our technologies are made in-house. We don't buy the companies and then try and fail to integrate the technologies in our technology stack. Everything is built from ground up with the same team of engineers. And again, as I said, we are a private company, so we are very flexible, and we can work with the newest technologies appearing on the market. Thanks again for joining, and thanks for your attention. If you have any questions, please use Q&A chat window to ask your questions. And have a great day.